Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 12E assignment. First one we're going to take a look at here is number 1. For each of the following data sets, make sure the data is ordered, and then find the median, lower and upper quartiles, range, and interquartile range. So here's our data for A. Make sure that it's in order. It is already in order, which will make this a lot easier to find all of these things. So median, let's count how many pieces of data we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we take our 11 and cut it into 2, that's 5.5. So that means there'd be 5.5 below, 5.5 above. Obviously you're not going to cut a piece of data in half, so here's going to be our 5 below. Here's going to be our 5 above. So that means that 13 is our median. So since that was the actual number, we take that number out to help us find lower and upper quartiles. So now we find the middle of these 5 numbers. So these, let's do this. These 2 numbers are above, these 2 numbers are below. So 9 is going to be our lower quartile. And then these 2 numbers are below, these 2 numbers are above. So 18 is going to be our upper quartile. So now that we have that, we can find, well, we don't even need that to find the range. The range is going to be, for part 3, take 21 minus 5, which is 16 for our range. And then the interquartile range is simply going to be the 8 for part 4 is going to be 18 minus 9, which is 9. Okay? All right, let's take a look at the next one, which is number 3. Jane and Ashley's monthly telephone bills are shown below. Find the mean and median for each data set. So these are not arranged in order, so you can go through and arrange them in order, or you can put them into the calculator too, and it will arrange it for you. So let's do one of each. So for Jane, we'll do it by hand. So here is Jane. Okay, let's see, 29 looks like it's the lowest, and there are 3 of those. So 29, 29, 29, and then let's see, looks like 31 is the next. And then we just kind of keep hunting for lower ones. So then we got what, a 34 and a 35 and a couple of 36s. And then a 38, 40, 42, 47. Okay, that should be all of our data there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So if we take 12 divided by 2, that gives us 6. So that means we're going to have 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6 above. So here's our median. So that means we're going to take 35 and 36 added together and divided by 2, which is 35 and a half. So for Jane, let's do, that's our median. Okay, and then for the mean, we got to add them all up and divide by 12, right? So let's do that. All right, so I'm going to simply just add those all up, divide by 12, and then that will give us the mean. Okay, so added those all up, and that gives us 426. So we should be able to take 426 and divide it by 12, and that should give us our mean. Divide that answer by 12, and we get 35.5. Okay, well actually that's just our answer. 35.5 is the mean, and 35.5 is the median. Interesting. Okay. next part is we're going to figure out Ashley's monthly telephone bill. So let's do that on the graphing calculator instead, and then you can kind of decide which way you would rather do that. So we'll go into Stat, and we're going to edit. I'm going to get rid of any existing data that we have, which is right there. So we highlight list 1 and push clear, and then either arrow down or push enter, and it should all disappear. And now we're going to simply enter all these into our calculator. Okay, so I entered all that data in there, and if I had any more, that would be the 13th piece of data. So that tells me there's 12, which we already knew. So that's a good sign that we've got hopefully all our data in there, and the data looks correct. So now we go into Stat, and we are going to calculate. It's just one variable, so it's one variable stats. Our list is list 1. There is no frequency on this, so we leave that blank, and we go to calculate. If there is something in your frequency and you don't want something in the frequency, you have to just push clear once you have that spot highlighted. Okay, so it gives us that the average, oh, this is a different one. That's okay. 30.75 is her mean. So let's do, what did we say it was? 30.75. So mean 30.75, and then the median will be 26. Okay, so we've got that all figured out. Find the range and interquartile range for each data set. Okay, probably should have read the rest of this before I went on to the second set of data, but that's okay because we still have that data, one set of data. Ashley's data is in the calculator, and the rest is out here. So if we want to find, let's see, the range is going to be 29 to 47. So 47 minus 29 is going to give us what? 18 is going to be that range. And then the IQR, oops, I changed colors because this is for Jane. In fact, I'm just going to go back and fix that so that it's easier to follow. So to find the interquartile range for Jane, we've got to find the middle of this data set. There's 6 pieces each, so that's going to be 29, average of 29 and 31, which is 30. And then average of 38 and 40 is going to give us 39. So the interquartile range is going to be 39 minus 30, which gives us 9. Okay, so that's Jane's. Now for Ashley, who we've got on the calculator, it will give us the quartiles. So 23.5 to 37.5. So this is Ashley. Our regular old range is, let's see, we can find that out too by taking the minimum. So 59 minus 19 gives us what, 40? And then the interquartile range for this thing is going to be 37.5 minus 23.5. And that is going to give us, what, 14? Okay, and then so for part C, which person generally pays more for their telephone bills? I would definitely go with our, I'd go with the mean, 30.75 versus 35.5. So I would definitely go with Jane on this one. So you've got a higher average. And then which person has the greater variability in their telephone bills? I would look at the range and interquartile range, and Ashley's are bigger, has a bigger range and interquartile range on that. So let's go with Ashley for the answer for that second one. Okay? Okay, so 6, A through M are 13 data values which have been arranged in ascending order. Which variable represents the median? So if we take 13 and we divide it by 2, that gives us 6.5. meaning we're going to have 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6 above. So that leaves G to be the median. And then write down the expression for the range. So the range is always the maximum minus the minimum, so we would just simply write down M minus A for the range. Okay? Last one is number 7. Data set has the following known measures of center and spread. Find new value of each of these measures if each member of the data set is increased by 2. Okay, so if the median was originally 9, all those pieces of data increased by 2, we're simply going to add 2 to our median to get 11 for our new median. Mode, the one that happened the most often was 7. If all those 7s got increased by 2, guess what? That's still going to be our mode, because we're going to take 7 plus 2 is going to give us that now 9 would have to be our mode. Okay. Now if we take the range as 13, that's the highest minus the lowest. So the highest, if everything got increased by 2, is going to be 2 higher, but also the lowest is going to be 2 more than that. So our range should stay the same. It's not going to change any. And the inner quartile range should also stay the same because, again, all the lower quartile got moved up by 2 and the upper quartile got moved up by 2. So when you subtract those from each other, you're still going to should still end up with 6. Okay? Okay, that's all we have for problems from 12E. If you have any further questions, please feel free to ask in class. Thanks.